Well, good morning, Algebra. Here's the do now for today. On your mark, get set, go. All right, well, once we square each of those numbers, we're going to get 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Hey, those answers are all referred to as square numbers. And that is a super important vocabulary word for what we're going to learn today. We need to be able to recognize square numbers out of our times tables. So they're called square numbers. You probably recognize from the illustrations. If you had a square with, let's say, take the bottom one there, with the side lengths of 3, in order to find the area, length times width, 3 times 3, you get an area of 9. So each of these answers that represents the area of a square of different side lengths, those are called square numbers. And today we are going to learn about factoring. Our learning target is be able to factor a polynomial, but not just any kind of polynomial, which we've been doing for the past several lessons, but a special type of polynomial called difference of two squares. So we need to be able to recognize, what does this special type of polynomial look like? Right, because we can factor the difference of two squares exactly the same as we have factored every other polynomial that we've come across so far, but there's a special way that we can factor difference of two squares. If we recognize, this is the difference of two squares, then there's going to be this special, faster way that we can approach it. So what does the difference of two squares look like? Well, first of all, difference refers to subtraction. So we're going to have a subtraction. And there are going to be two terms. So a polynomial could have any number of terms. This particular type only has two terms. And each of those two terms is a square, like those numbers we just saw in the do now. So I could pick like 4. It was one of the numbers in our do now. And 9. And this will give me two numbers. I'm subtracting them. Both of them are square numbers, but this is not exactly a polynomial. It's just a subtraction problem. 4 minus 9, and we subtract, we get an answer. So in order to be a polynomial, I need to have different types of numbers. So I'm going to put an x on one of them. That gives me two different types of numbers. But the problem with this is 4 is a square number, but x is not. I don't know what x is. Maybe it is, maybe it's not. But in order to guarantee that the x term is actually a square number, I can't just have 4x. It's going to have to be 4x to the power of 2. So I already know that the 4, the coefficient part, that's a perfect square. And now whatever number x represents, it is squared, because that's the way the polynomial is created. So I've got two terms. Both terms are perfect squares, both the coefficient part, the variable part for the green one, and also the blue constant. Everything is a perfect square. It's subtraction. There are two terms. Difference of two squares. All right, so let's see how this factors. So we'll just keep going with that same example. So here's the longest option. If I just said, you know what, I'm going to factor this just like everything else I've ever factored, fine, we totally can do that. So let's start there. So in order to factor a polynomial, first thing I need is, I'm going to need 4 terms, right, to fit into my my factor box. And this does not have 4 terms. It has only 2 terms. And so it's like, well, that is different than what we've been doing before. So I know I could insert a middle term right here. So I've got 4x squareds. I got minus 9, but normally there'd be like an x squared term and then an x term and then the constant, and this one seems to have been left out. So how many x's are there in the original problem? Well, there aren't any. If there are no x's, I could actually just write that with a 0. And so now this looks like more of what I'm used to seeing. I've got my 3 terms. And so in order to factor this, I need to take that center term, the 0x, I need to split that into 2 pieces so that it'll have 4 terms to fit inside the 4 box. And I know this seems kind of like maybe we're going the wrong direction. Like it started off with just 2 terms, and now I've made it into 3 terms, and I next make it into 4 terms, and it keeps getting bigger and bigger. And you're like, no, I don't want it to get harder. Well, yeah, I get that. But we got to go forward with our steps. So multiply the x squared coefficient and the constant. That is our first step. So that's going to be the 4 in green and the -9 in blue. Those multiply. 4 times -9 gives me -36. And then my next step, list all the factors of that product. So get some space. I'm going to list all the factor pairs that would multiply to get me -36. So I could do 1 and -36. I could do -1 and +36. 2 and -18, -2 and +18, 3, -12, -3, +12, 4, -9, or -4 and +9. 5 doesn't work, but 6 does. 6 and -6, or -6 and +6. But really, that's the same pair of numbers. If I switch the order, it doesn't actually change the fact that it's those same 2 numbers. So there's my whole list. Next, I'm going to go back through that list of factors, and instead of multiplying, this time add. I want to find out which of those pair of numbers would add to get me the x coefficient. So the x coefficient, that's going to be this purple 0. So if I'm going to go through this list and add, which of these pair of numbers would add to make 0? 1 and -36 does not add, make 0. That's -35, +35, -16, +16. No, 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 no. This one, only one that's going to add to make 0. +6 and -6 add to make 0. So next step, break the x term in my polynomial apart into 2 pieces using those 2 factors. So I'm going to rewrite that polynomial for x squared plus 6x minus 6x, and then the -9 goes over here. So now I'm going to put those 4 parts inside the factor box. Let's just look at the rest of the steps. We're going to go forward from here without having to jump pages. So put the 4 terms into the factor box, find the common factors, and then write my final answer is a multiplication problem. I'll use parentheses to do that. Okay, so 4x squared plus 6x minus 6x minus 9. All right, let's go across the top row. First, greatest common factor, the 4 and the 6, those are both multiples of 2. And when I look at the variables, I see both boxes, there is an x. So they have an x in common. So that x is going to go here. Oops, let's do this in blue. All right, so that red 2x multiplied by what will give me 4x to the power of 2? Well, it'd have to be 2 multiplied by another 2 to get the 4, and that red x multiplied by another x to give me x to the power of 2. All right, next box. That red 2x multiplied by what will give me the positive 6x? Well, I have to multiply by positive 3. And let's do this last one over here. So on the top, that blue 2x multiplied by what number in red will give me negative 6x? That's going to be multiplied by negative 3. So my 2 factors, 2x plus 3 times 2x minus 3. All right, so as you might have noticed at the top of the page, this is the longest possible way to factor this. All right, so let's see if we can come up with some ways that are not so long. All right, so the original polynomial did not contain a middle term. It meant 0. We didn't change anything. When we wrote the 0 there, we just wrote it. And then we had to take the 0 and break it apart into pieces. Did we really need to do all of that? Well, yes and no. Yes, we did, because that's what our factoring process is. But could we have gotten away without doing that. That would have saved us a lot of work if we could. So since the plus 6x and the minus 6x cancel out in the end, and we know these two terms are perfect square numbers, we could simplify our approach here, because all we need to focus on really are saying in those two green squares, they're square numbers, right? And so the side lengths are going to be the same. I have 2x in red and 2x in blue. They're both the same. And for the -9, the sides of the square, if you will, +3, -3, so those are not exactly the same, right? You can't have a square that's got +3 on one side and -3 on the other side. And so um, if we just consider the 9 portion, we can say that's a square number. And in order to get a negative answer, we're going to have a positive and a negative multiplied together to get a negative answer, right? But to simplify our approach, we could get away without doing the plus 6x and the minus 6x. That would save us this step. It would save us having to put the 0x in the first place. It would save us having to create this whole list of factor pairs. And it'd save us a lot of work. Let's try it with this one. Here's a shorter option. So let's simplify our approach. So we're going to take the 16x squared. It's going to go in the first box. That minus 25 is going to go in the next box. I recognize both of these are perfect squares. It's a subtraction in the original polynomial. So this is the difference of two squares. I've identified that. And now I can look at that 16x squared and say this is a perfect square number. Oops. What would have to be the side lengths? If this is a perfect square, what are the sides that I could multiply the length and the width to get that area of 4x squared, where both the length has to be the same as the width? So it have to be 4x and 4x for both. And for this blue one, again, if that is since it is a perfect square, I can have the length and the width exactly the same, 5 and 5. But it is a negative 25, and so that means really it's not a, if I include the negative sign, it's not actually a perfect square. The 25 part is a perfect square. But in order to make the factor process work, you're going to have a +5 on one side and a -5 on the other side. And then my factors, 4x plus 5 and 4x minus 5. Right. And then in this case, I did not need to fill anything into these other parts of my factor box. So this is much faster than the first approach. Let's see if we can simplify this our method, if we can simplify that even more. So here's another option. If I do this entirely mentally, okay, two terms. I see it. Subtraction. Got it. 9x squared, that is a perfect square number. 49, that is a perfect square number. So once I've identified this is the difference of two squares, then I could eliminate a whole bunch of stuff. I can get rid of all of those extra steps from our factor process that we've used in the past. I can get rid of the factor box even and just go straight to my two factors. So from the 9x squared, if that is the area of my square, I need to get two side lengths, length and width. I'm just going to write them straight into my parentheses. 3x and 3x. That's what's going to multiply together to give me that green 9x squared. And then for the blue part, 49. That's 7 times 7, right? 7 and 7 go in the last part of each set of parentheses. One of those is going to have to be a +7, and the other is going to have to be a -7. Otherwise, it would not multiply to give me -49. And that's it. I forgot some arrows. Pew, pew.